Hello, my name is Simon Wallace Phillips and this is the presentation for my dissertation. As an overview, I intend to cover the hypothesis, rationale, a brief overview of literature, implementation plan, testing and analysis plan, results and conclusion. Through the use of virtual reality, the Welsh paramedics require a training procedure that provides skills maintenance such as intubation that is currently undergone through the use of physical tools on a mannequin. Intubation procedure is applied on patients with breathing difficulties using inserted tubes that control the process of breathing. This is achieved by directing and controlling a flow of inhaled and exhaled gases via the inserted tube that supply vital oxygen to the patient's airway. To prevent leakages, a syringe injection of air inflates a small balloon to an airbag that, when inflated around the tube, prevents forced gases bypassing the airway returning immediately back out, rather than supplying vitally needed oxygen to the patient's lungs. My hypothesis is virtual reality can add value to the traditional training methods used by paramedics for learning the process of intubation. Through the use of lenses, screens and sounds contained within the MetaQuest 2, many software developers use Unity 3D as a development tool to create an environment with objects that provide the user with a real, immersive experience. This removes any external distractions, controlling the trainee's environment where stress factors can be applied within the scene in a safe and controlled way. This would be facilitating familiarisation, controlling how the trainee reacts in the real world under similar conditions. Having spoken to the Welsh paramedics on their view in the use of 3D peripherals, the review was we should work less with restricted devices and more away from the physical constraints of that particular device. When staff were given the opportunity to use the touch, the current developed software, they felt this discoordinated away from the project itself, provide a level of visual interaction outside the virtual reality scene to connect with. To conclude, VR training should commence through the series of environments that impacted the step-by-step training in such a way that could be more realistic. The trainers at the Welsh Ambulance Service Centre did say that the need to have specific storage and training areas that often went unused, where they had to store devices in order to physically interact and create the intubation process. And then when it came to coordinating staff in order to provide training, the need to be in one particular place at one particular time with trainers and trainees became very awkward and often impacted on timetables to a point that it was almost impossible to train many students at one particular time, and therefore the training process sort of became disjointed. There has already been progress made with a company called Arch Virtual. They have demonstrated the use of MetaQuest to showcase their software that facilitates an environment not dissimilar to a hospital. The user would wear the equipment and interact with physical components laid out before them, and when used as part of the virtual environment, made an excellent solution towards the development of training software for intubation in a virtual environment. The software has not incorporated any of the more realistic paramedic scenarios where they would be first at the scene of an emergency, like, say, a car crash, possibly on fire. This could put added pressure on the paramedics to perform a procedure that is infrequently used. This is one of the major factors that impacts on the success within intubation, where the environment influences the reduction of production because of the increased stress levels. The University of Illinois has also produced a very good simulator for training in the process of intubation, but once again, a controlled environment not dissimilar to a hospital. The implementation plan would be to include a scene where the first scene would include the ambulance and the paramedic, where you could implement tools like the laryngoscope on the patient, apply other airway tools and supply vital oxygen and monitor the gases going in and out of the patient. To visually demonstrate this, I've showed a series of stages going from 1 to 6, going through the range of topics previously discussed. Ideally, this should be done within a scene which could incorporate bad weather conditions and hopefully provide a level of visualization that would appear to be as realistic as possible. This could incorporate an industrial area where access to the patient may be limited in some way through a series of steps or building restrictions and boundaries where paramedics would need to go away from the ambulance to find the patient and administer the appropriate procedure. To achieve this level of interaction, there needs to be a good understanding of developmental tools such as Unity 3D, drawing tools such as Maya or Blender that use 3D architecture to create usable objects like the laryngoscope seen here that can be saved and imported as an FBX image file format into Unity to be used as an asset within one of the scenes, along with possible needs to create meshes to set up polygon colliders with objects that Unity cannot create. As a result, significant training would be needed to be undertaken in order to facilitate the use of the head-mounted display in the virtual reality environment, as this is significantly different when it comes to interaction processes facilitated through PC screens, mouse, keyboard, controls, etc. The Unity editor has four main areas. Similar to a scene in a movie, Area 1 consists of a central viewing point. This consists of any used asset's geographical position within the project scene. Area 2 stores all assets that are loaded within the scene. Area 3 holds a list of all assets loaded and available for use within the scene. And Area 4 has the properties and attributes of each individual asset once it has been highlighted within Areas 1, 2 or 3. Going up the stairs. Up the stairs, around the corner, notice the splashes on the new raised level. Okay, coming to a table with 3 objects, of which 2 are using the inverted objects. Now already notice that you can put your hand in. I'm actually banging the hand against the edges. I can go through from the outside, but I can't pass through the opposite way. So the boundary is internal, not external. Grab the tool, come round, select the appropriate position, not the easiest to do. Let go. There is a pause button on the right hand side which will control any action within the scene. I'll click it, and notice all the rain stops, and pause it, rain continues, stop, and start. That's just about it. There needs to be professional, legal and ethical consideration throughout the dissertation. For example, no unnecessary scenes of gore, violence or inappropriate language have been included. As part of representation, I have included a black character as the patient. For testing, there would be a significant amount of white box testing to be done to make sure the program runs as smoothly as possible so the user can interact with the environment using appropriate tools that are fundamentally required to do the intubation procedure. At this stage, there is no need to do any black box testing, as the end user will not be involved in this part of the development. It will be tested for functionality and usability along with the reliability of the software systematically throughout the development to make sure that it meets the end user requirements as a user-centered production as much as possible. There ideally needs to be improvements made on terrain like cliff edge scenarios, and have options to change the scenarios from day to night, rain or no rain, through a series of switches. A particular choice of scenes will give paramedics more options to apply their skills over a greater range, rather than familiarise themselves on one particular scenario challenge. Ideally, the process would have a range of co-workers that would interact with the player. More immediate attention needs to be addressed on some of the fundamentals in the current program where the height of the player is initially set incorrectly, and a range of tools needed to be applied throughout the intubation process and a step-by-step procedure, which fundamentally prevented due to the program not understanding the internal boundaries between the mouth and the inserted objects. Therefore, on working with flipped polygon faces and different types of meshes does need to be applied to a standard that controls the position of any tools inserted into the patient's mouth. This issue can clearly be seen from the example given by the University of Illinois. That concludes my presentation. I hope you found it informative and it paints a clear picture on what was proposed at the start of the presentation. Thank you.